and welcome to another episode of FooBar. Today we are doing one of those interviews that you like so much. And because we are talking about Kinesis, what else will be the interview about? I will be talking with one of the queens of Kinesis, our data hero, Anahit. She will be sharing her experience with Kinesis in real life, all the lessons she learns, and some horror stories as well. So let's get started. Hello, Anahit. How are you today?
I'm great. Thank you. How are you?
I'm good. It's been a rough morning. So if you're watching this, you need to appreciate this.
But we struggled through it and we are here now. So let's hope everything goes well from now on.
It will be perfect. And you just need to give a thumbs up for us being able to record this thing.
Yeah, a lot of things have happened behind the scenes before this flight, yes.
And it's only 10:30 in the morning, just for you to know. But yeah, so for the people that don't know you, who is Anahit?
I'm Anahit, and I'm an AWS data hero. I'm also a lead cloud software engineer at a company called Solita. And Solita is a digital transformation company that originated in Finland many, many years ago. I stopped keeping track, but nowadays we span over 6 countries and I think 20 cities across Europe, or maybe a bit more. So we have grown quite a bit also during this time. Yeah,
nice.
Shortly about me.
Yeah, so why you became a data hero in the first place? Because you might have an origin story.
Well, I think it's more of a question towards you or any other person who works in AWS, because, becoming a hero, AWS hero, is something you yourself as a person cannot do much actively anything about. You just get this wonderful email.
You did a lot of actively of being awesome.
Yes. Yeah, well, thank you very much. But yeah, I've spoken about Kinesis and data issues for some time now, and written some blog posts and recorded some videos and all that stuff. And apparently folks at AWS saw that and thought it was cool. So here I am. I'm very happy to be one of the heroes because it's an amazing group of people, very talented people. So it's really an honor to be one of those. So yeah.
Yeah. What is your story with Kinesis? How long have you been working with this?
I would say maybe started about 5-6 years ago. I already, lost track of time with COVID and with having a baby. So I really don't remember, but I would say about over 5 years when I started working with it, and I had zero experience with it. It was just okay, here is our system. We use Kinesis here. Everything works. And then, go figure. Turns out not everything worked. So I kind of had to go into a lot of details and was writing a lot of notes to myself, which in the end turned out to be 2 huge articles about Kinesis and then all the talks and everything. So yeah, been a long way since then.
Yeah, that's a big ride. But that's the opportunity. Sometimes you have a random project that will take you to be the common denominator for your career in the next 5 years.
And you never know when it's going to happen. It's the surprising element in life.
Yeah, and you have been doing a lot of Kinesis talk, at least lately. After the borders open, you're everywhere. So, and you will be in reInvent as well.
Yeah, I'm going to be speaking at reInvent this year, which I'm extremely excited about because this is
about Managed Kafka,
No, Kinesis. Surprise. Yeah, still the same topic. I might stop talking about it at some point. But the thing is that at least lately I've been trying to, compose my talks in a way that will convey a message that this is really not Kinesis specific per se. This is something things that I talk about. They are very common to distributed systems in general. So it's more like a philosophical talk in the end, but with examples based on Kinesis. And actually recently, just this Saturday, I had a talk in Oslo, and one of the guys listening afterwards said that, if you would replace the names of the services with, for example, some other cloud provider services, it will still be the same. So basically kind of all those considerations of course, there are some details that are specific to services or cloud providers or whatnot, but I think those are important discussions and considerations to have in general.
Yeah, and I think today we are going to cover some of those philosophical notes and also very specific to Kinesis in real life because you have suffered a lot and enjoy a lot with it. So.
Well, I wouldn't say I suffered, but let's say I learned. I grew, I experienced.
I grew. Yeah. That's how it goes. Yeah, so maybe you can give a short intro to, I think we are focusing, because Kinesis is a family of products and your focus will be on Kinesis Data Stream. So maybe you can give a brief introduction of what is Kinesis Data Stream for the ones that have not watched my 27 million video series on it.
Yeah, excellent. So yeah, please go watch the 20 million plus series that Marcia
People
has
don't
recorded.
have time for that. They're here.
I know. But for those of you who don't have time, so really quick introduction. So yes, we are indeed talking about Kinesis data streams, which is a part of the larger Kinesis family. But I think when you say Kinesis, it usually refers to the data streams nowadays. So let's just stick to that name. And basically, it is a fully managed and massively scalable service on AWS to stream data. Right. So data streaming applications are sometimes like a bit different from maybe like general passing events from one service to another in event-driven architectures. So Kinesis is in general designed for this continuous flow of data versus these individual events. But that being said, you can also use it for individual events as well in your event-driven architecture. So I hope I haven't confused you completely by this point. But let's say originally it was designed for big amounts of data. So,
but before Event Bridge, it was a very common tool for doing event-driven architectures.
Yes, and I would say it still is in some cases. Yeah. So it's a very useful tool in my opinion. And the thing about it, and again, if compared to Event Bridge, it actually still is a bit faster, so a bit lower latency. So we talk about near real time here, which means that after we write the data to the stream, it appears within milliseconds, and then you can actually read it pretty quickly as well. So as low as 70 milliseconds, I think nowadays is what Kinesis can offer you. And moreover, after you write the data to the stream, it stays in that stream for at least 24 hours, or you can configure it to be up to a year. So it's basically the data can be stored in your stream for up to a year, which makes it a great opportunity, like gives you a great opportunity for all the retries, maybe processing or replays or all that kind of stuff.
Yeah, but don't use it as a data store, please.
Yeah, good disclaimer.
Very
then again,
expensive.
Who are we to say if the customers want to use it and want to pay for it? Then, in my opinion, go for it. But yeah, it's not meant for acting as a data store, of course. But it has this very extensive data retention capabilities, which is, I think, the most of all the services like SQS SNS and Event Bridge at most support like several days. So this is one distinct feature for Kinesis.
Yeah.
And it's a very powerful tool in general because, well, there are no servers to manage, no clusters. So it's fully managed, as I said, and it scales pretty much endlessly. It doesn't really have an limit, at least not an announced limit, but there's probably going to be a limit at some point. And it also integrates really, really well within the AWS infrastructure itself, meaning that there are many services that can write or read from Kinesis, so it can be very useful. And also you can have your own custom stream consumers to, do whatever you want with that data in near real time. So as I said, that's where the magic happens.
Yeah, I think there is always, when we talk about Kinesis, at least a question I have to answer quite often is like Kinesis or managed Kafka or Kafka, and they kind of similar solution for similar problem. One is just an open source solution. One is an AWS specific solution. Kinesis has a lot of integrations, like super neatly packed into the AWS ecosystem. Managed Kafka or Kafka is more open source, so there is more configuration that you need to do. I don't know if you have something else from your experience to add to that, but that's a common question I hear a lot.
Yeah, I hear the same question basically all the time because I think Kafka is so much more familiar to folks in general. So Kinesis is so AWS specific. So of course, everybody wants to know what are the key differences. And I think what you said about Kafka having much more to configure, even if there is this fully managed option on AWS nowadays, you still have to configure it. But apparently, if you configure it correctly, it can cost a bit less than Kinesis. But then, I mean, there's this total cost of ownership discussion, like how much extra you are paying for all that configuration and, management. So,
yeah.
I mean,
and the integrations that Kinesis have, if you are 100% in AWS, how it integrates with other services, like when you use Kinesis with EventBridge, with Lambda, with Firehose, with Flink, it's just so magic, all these integrations that if you use Managed Kafka, you need to do a little bit more work there in those integrations.
Yeah, again, like maybe a bit like being devil's advocate, I think that AWS has been adding a lot of integrations to Kafka as well. So it works
because people use it.
Of course. So it works in many ways similarly to Kinesis. In general, I have been saying about that maybe like already 2-3 years ago, but I started to get this feeling that all the messaging services, all these integration services are kind of merging together. They are coming closer and closer and closer to each other because like there are features that of course users like in one service, and then AWS hears that and add those same features to the other service. So they end up to being very close to each other, which is a good thing, of course. But on the other hand, it can be very confusing if you kind of try to pick one service and then like, what am I going to choose from all the services? They look alike.
Yeah, that's a totally hard question for us developer advocates to answer when people come, should I use this or that? It's like,
Well, it depends. Exactly.
So that's our answer. It depends. So you mentioned that Kinesis Data Stream is serverless. Is that serverless?
Well, I didn't actually say that. I said that it's fully managed. I tried to avoid the word serverless as much as possible because...
I heard no servers to manage. Sorry.
Yes. So, yes, that's exactly what I said. I'm a bit conflicted about that because, here you will find in AWS documentation this statement that Kinesis is serverless. And I don't know. I mean, of course, there are other folks like fellow AWS hero Benkio, who has been telling that serverless is actually a spectrum. It's not binary. It's not either yes or no. But I tend to say still that Kinesis is still not fully serverless. I can explain what I mean here. So with Kinesis, there is this thing called shards. So each Kinesis stream will be composed of multiple shards. So it's just a unit of parallelism in our stream. And each of the shards will come with this limited capacity of either 1 megabyte or 1,000 records. But each shard is limited. And the number of shards in your stream will define the available capacity that you are going to have in your stream. So basically, you provision as many shards as you want to stream as much data as you need. See, this already doesn't sound too serverless to me personally. When you have to provision your capacity, right? And then, like on the other hand, the amount of data when we are dealing with streaming applications, or in general, it rarely stays the same, right? So the data fluctuates, it changes over time. You get more data, you get less data. And then if the amount of data that you get gets larger than your stream can accommodate, so that larger than the capacity that you have with the available shards, you will have to scale your stream up, right? You will have to add more shards to your stream. So this is a process called resharding. There are like API calls for that. You can, or you have to use those, or then you can implement this auto scaling, which is not a part of the service. You have to implement it yourself, but it's possible to automate this resharding process. But again, this is not part of the service. And of course, there's always this possibility to over provision your stream. You just kind of throw a huge amount of shards to it and like don't want to worry about any fluctuations in data. But as always, there is a catch with it, because with Kinesis, you pay for the data that you stream, and also you pay for every open shard in the stream. So in essence, what you're getting is that you provision capacity with your shards, and then you pay for that provision capacity. You see, so this to me is kind of not so serverless service in my books, right? But the question is, why does AWS claim that it's serverless? And maybe it's a question to you, Marcia, but I have my own version of an answer. And it's that nowadays there's this thing called capacity mode. So you can actually specify capacity mode for your stream, and you can choose from either this good old, not so serverless provision capacity with all the shard management that you have to do. And Then there is this newer on-demand mode, which kind of promises you no shard management, auto-scaling, and fun stuff like that. But shards are still going to be there. Shards don't go anywhere because that's how Kinesis stream works in any case. So shards are the base of your Kinesis stream, but with on-demand mode, you are just not going to see those shards. They are going to be abstracted away from you, hidden away from you, and you are going to have like zero control over those shards. But the problem with this, and tell me if you have something to add to that.
Yeah, no, I was just saying that the pricing is also a little different with on-demand than with provision.
I was just getting to that. And the thing is that, first of all, the pricing is different, but let's maybe start with the fact that actually the on-demand mode can handle only double the capacity from the previous 30 days. So what I mean here is that I would expect an on-demand mode to work, with dynamical scaling up and down and things like scaling maybe to zero even, like DynamoDB does. But what it does instead is just like over provisions your stream behind the scenes based on the maximum amount of data that you got during the previous month, right? So, and if you get the spikes of data every now and then the amount of shards are going to stay the same or high pretty much. They are not going to come down. So there are only shards. But as you said, the pricing model here is a bit different. So here we don't pay for individual shards anymore. And in theory, we shouldn't care how many shards there are. But again, on the other hand, my personal guess, again, correct me if I'm wrong, is that though the shards are still there, right? They are reserved for you. Either you use them or you don't use them. So the pricing model is made so that you probably are going to pay more for the on-demand stream than provision stream. Like my personal experience from here.
What happens with any service that is serverless is a little bit more expensive because.
Yeah, but a little bit is good. But like I've tried to estimate it, and it was like, again, about a year ago, things might have changed since, but it was about like 2 to 3 times more expensive, even if you over provision your provision streams. So it's kind of, but that being said, I absolutely love this option still, even though I might sound critical, but it's a great option to get you started. If you know nothing about Kinesis or you know nothing about your data requirements, actually. So you just want to like spin up a stream and start streaming data. On-demand mode would be great for that because you just basically spin up a stream, don't care about anything, start streaming, and then maybe later when you have a better understanding of your data, of your requirements, then you can actually switch to the provision mode. And you can do these switches back and forth, I think up to two times per day. So it is a very convenient option, but I would say currently it's more of an option to get started rather than an option to use always in production. You say, like from my perspective at least. So that's why I personally don't, I still hesitate to call it fully serverless, and I'm still expecting for that, true auto scaling with like this beautiful dynamic scaling and scaling to zero. But well, that's just me. So that's my reasoning behind it.
I know the definition of serverless is sometimes depending who is giving it.
Exactly. And
what it means,
it is a spectrum. I kind of agree with Ben. And we shouldn't be so critical about wording maybe, but it's more about maybe in this case, my personal expectations from where I would like to see the service going, or maybe like expect at some point, maybe it will still go there, who knows? But currently that's how it looks like. So yeah, shards are still there. They are not disappearing anywhere. So it's always a good idea still to understand the basics in the end, how this works and what are the shards and that kind of stuff.
And even though in the on-demand mode, you don't need to worry about the shards, I think it's important to know that they are there because shards have implications later when you consume data from it.
Exactly.
So it's, even though like you don't need to worry to provision them, but for example, when you start with on-demand, you start with 4 shards. And if you, for example, you connect a Lambda function, there will be 4 parallel Lambda functions working together. So that already is something that you need to understand a little bit, that things are happening like this in the back end of your backend.
Exactly, and that's one of the reasons.
Some of the errors.
That's one of the reasons why I say that it's more for getting started at the moment, because still without like better understanding of how things work, you won't get too far, at least in a proper way. You probably are going to end up in a lot of trouble if you don't really understand, because with great power comes great responsibility, and Kinesis is a powerful service, so you have to be conscious and mindful about how you are using it.
Talking about great responsibility, I would love to hear one of your stories with Kinesis, because I know you have many.
Well, I guess I kind of combined all my experiences in one simple story here that I can share, which is basically about how we have been using this Kinesis data stream with one of the customers. And we had this very simple but still very powerful architecture where we had the producer and then Kinesis, or writing data to Kinesis. So we wanted to use this so-called storage first pattern where we want to kind of persist the data or capture the data before we process it. And yes, though Kinesis is not a data store, but is a reliable place to put your data before further processing, right? So we had the Kinesis data stream, we had a producer that wrote the data to our stream, and then on the other end, we had an AWS Lambda that was reading from that stream, like processing that data. And everything kind of looks great and everything worked out of the box until it didn't. So someday we just started to realize that we are actually losing data in production. And that realization didn't come from logs or metrics. We by all means had those, but we couldn't spot anything, extraordinary in neither logs or metrics. I guess we didn't exactly know what to look for at that point. But instead, we started to see our consumer Lambda behaving really weirdly. Like I like to say that it was acting like write a ticket to AWS support kind of oddly, meaning that you are kind of out of ideas of what's happening here, and your last resort is just to write a ticket to support and ask like, hey, can you help me? What's happening? And basically, that's exactly what we did, and had long and fruitful conversations with AWS support, and it kind of started to unravel and unfold from there. So basically, we went all the way to the beginning and started to check the entire pipeline, step by step, to see maybe we have other issues. And of course, we did have other issues. And we, first of all, realized that we are losing data even when we are writing it to the stream. So in the very first step, where we thought that we are using this wonderful storage first pattern, we were still losing the data because, there were things happening behind the scenes and we had no idea. And it was a very embarrassing moment.
Maybe we can rewind a little bit why we want this pattern. I think this is a great pattern in order not to overwhelm a Lambda function with a lot of records coming in. So then the Kinesis will be like the buffer, and then will be like Lambda will be handling the events whenever it can handle the events. So this is an amazing pattern for doing that when you have a lot of data, no?
It's a great explanation, yeah. And as I said, it's really simple, but then it gives you a lot of power because you don't have to react immediately to the data that comes in. You have this buffer, as you said, and then you can actually kind of decide later what to do with the data. So Lambda, again, can have issues like throttling or whatnot. So with this pattern, you would be sure that your data is safe in the stream and you have time.
You will be sure.
Well,
until you're not.
Until you're not. Exactly. Good point. But that's the great responsibility part, right? That we are going to discuss in a moment. But it's again, like most of the good patterns, they're actually very simple, and this is one of them. And I personally like it a lot. And again, think with Kinesis that I don't think you mentioned is that you can actually have several consumers that will read from the stream. So you don't have to have just one consumer, like with SQS, for example. You can have multiple consumers reading from the same stream at the same time. So it kind of gives this like wide variety of opportunities, really. After once you get the data to the stream, which turned out to be not so straightforward as we thought it's gonna be. So yeah.
So what happened?
Well, that's a good question. I mean, first of all, maybe like very quick mentioning about how you usually write data to the stream. So there's like a huge variety of options that you have there, like direct service integrations, libraries, third-party tools, that kind of stuff. But our specific producer, it was using the most flexible way to do so. So basically AWS SDK, which is basically the layer of abstraction above API calls. So you can do the most with AWS SDK. It gives you the most control, but again, most responsibilities as well. And when you use AWS SDK, there is actually, or API calls per se, there's actually two distinct ways in which you can write data to the stream. So you can either stick with writing individual records with this put record API, or then you can batch up to 500 records in one request and send it out as one request instead of 500 separate records, right? You basically will provide an array of records and send them in one HTTP request. And this is a great way of sending huge amounts of requests. And this is, again, not Kinesis specific. This would work with all the services that support batching. So like DynamoDB, maybe SQS. I would always recommend using batching because it can reduce the size of the HTTP request that you send, because there's a lot of request overhead that comes with each individual request. And it will also, of course, reduce the number of requests that you end up sending, which in turn can reduce latencies in your producer application. So it's a very useful tool to have. And personally, I always prefer to use batch operations. But again, these come with their own considerations and responsibilities, as it turned out. So maybe again, like trace back a bit what happens when a request to Kinesis fails, because I'm here to tell you requests fail. You know, if you didn't know it before, now you do. And the good news is here that AWS SDK will actually take care of most of it on your behalf. So if there's a failure because of so-called like retriable errors, like, you know, your service being unavailable or timeouts or whatever, AWS SDK will retry that request for you for up to 3 times by default. And it will use this exponential backoff, which basically means that the consequent, or the times between the consequent retries increase exponentially. And this is done so that the retry attempts are spread more uniformly across time. So you kind of don't send this, you know, burst of retries all the time. You just try to spread them out so you don't overwhelm your stream. And those are the parameters that you can, or some of those parameters you can configure. For example, we're creating a Kinesis service in Node.js SDK, like I have an example here. And you should also configure timeout related settings, because by default, SDK will wait for 2 minutes. And remember, we are talking about real time data processing and milliseconds here. But SDK will actually wait by default for 2 minutes before it decides that the request timed out. And there's actually 2 separate settings for timeouts, for new sockets, for existing sockets. So you add those up, then you add up all the retry attempts, and then you can, or your producer might be waiting for like minutes and minutes to send just one request, you know, before it sends the next one, which is kind of not too desirable. So, and again, this is something that is related to basically any service or any API call that you do to AWS. You always want to check the default timeouts, and you always want to configure them, you know, correspondingly. So 2 minutes is like just obscene amount of time to wait for a Kinesis request. So
and more your data might already be old by the time you send it or something.
It probably is gonna be old. I mean, like 2 minutes. Nowadays, it's a lot. I mean, even if you're working with just event-driven applications, it's still in many cases. If you're working with
event-driven applications, 2 minutes, because you need to react to those events. It's like the user click a button and then it goes for an app.
Well, yep, exactly. If you have like front-end facing, then that's it, like 2 minutes, come on. And actually, I stumbled upon it first time, I think, with DynamoDB, actually, which was, again, like, okay, we are waiting and waiting and waiting. Maybe we shouldn't wait anymore. It was eye-opening. But it's a very simple thing, but somehow a thing that many people forget about. So I try to remind people to please check the defaults. Never go with the defaults. Defaults are dangerous. So just kind of keep an eye on those. But I guess, like, with all this talks about failures and stuff, we should also discuss a bit why the failures actually happen in the first place, right? Because I said that requests will fail, and that's because basically, well, there are several reasons for that. First of all, of course, we are working in distributed systems over networks, so there are tons of network issues that can happen. We all know about it. There can be
and this is a connection usually from a client to AWS. So
Exactly.
there is the internet going on there.
There is the internet, and then there is like tons of devices in between with all the routers and application load balancers.
Things can happen.
Gateways. Things will happen. I would even say it like that, because and it's not something AWS specific. It's just the kind of the reality of the internet world nowadays, or any days. So those are the things that you will see for sure. But then there is this also very common thing called throttling. I think we maybe have mentioned it before without like explaining what it actually is. And if you're not familiar, well, it's basically you exceed one of the API limits, because everything has limits, also API calls. And once you reach that limit, all the new requests to that API will be rejected. So they will fail. And this is called throttling. And with Kinesis, we have this limit for shard throughput. So we have this 1 megabyte, 1,000 records. And if we reach that limit, so write too many records per second, then the new request will be throttled. So that's a very common reason for requests to Kinesis to fail.
Yeah, and this is very random because it's per shard. So you can have a very hot shard and a very cold shard. And
exactly.
You're like, why?
That is one thing, because again, if you're not used to working with Kinesis, you wouldn't understand that the data might be spread across the shards, not so uniformly. So you might end up having shards which have more data and shards that have less data. And then if you have shards that have too much data, well, that shard will be kind of throttled. So these are the things that you need to take into account. And there are ways to not make that happen. You can actually influence that. But then there is also another confusing aspect, which I have here on the slide, is that the limits for Kinesis that I mentioned, like the throughput limits, are per second. So you have 1 megabyte per second, 1,000 records per second, right? But the CloudWatch metrics are by minute aggregates at the very best. Like you will never have minute to minute or second to second picture of what is happening in your stream with CloudWatch metrics, right? So they will aggregate the data over entire minute. And the thing is, we never know how the data arrives to the stream. So you might be sending it very like in spiky manner, or it might be just arriving there with some spikes because, well, internet and traffic and traffic jams and stuff like that. So you might actually have a completely different image second to second compared to minute, because you look at this minute to minute beautiful graph that says, well, you have tons of space until your stream capacity is reached. You don't have that much data flowing. But then the reality is that you have these spikes of traffic that cause throttling on individual shard level. And this was like one confusing thing for me personally. And that's what I said, meant when I said that metrics didn't tell us much, is that on one hand, you're looking at the metric that tells you about the stream throughput. And there is like vast amount of space left. We had a vastly over-provisioned stream. And then you are looking at those metrics that are telling you about throttling, and there are actually two of them, and they are like the spikes of throttling metrics. And like, how can that happen? It's not true. Something is not. I don't believe it. Of course, it was happening exactly because what I said, like per second versus per minute, are two completely different worlds in that case.
Yeah, that's hard to find. Is there a way to find out like how your stream is receiving that per minute thing with some third parties or yeah?
I personally haven't encountered anything. What I would recommend always to do is just keep an eye on like various metrics. So it's not only the stream throughput, and even more so, always keep an eye on failure metrics, because those are the most interesting ones. Anyway, they will tell you, they mustn't trust them when they tell you that something fails. Then it means that something really fails. So that information is already a pretty good jumping off point, but just like looking at more metrics and trusting the metrics rather than, oh no, it can't be happening because I know I have, enough capacity in my stream. No, you don't.
At least in that second.
Yeah, at least not at that second. Exactly. But actually, the conversation about failures is just beginning because the main revelation wasn't even that. It was a said revelation, but the main revelation was a bit different. So, okay, I'm I told you that SDK will take care of most of the failures for you, right? It will retry the failed records, and with this code on the left, it will log the errors if the records or the requests still don't go through after the maximum amount of retries, right? So you look at the logs and you see nothing, and you assume that nothing is happening, and that's exactly what I did. But the catch here is that the word most that I use there. So SDK handles most of the issues for you. And the thing is that in case of batch operations, like we have put records here, it's a batch operation. Instead of just handling the failures of the entire request, you should always handle the so-called partial failures. And partial failures happen because these batch operations, they are not atomic. They don't go so that either everything succeeds or everything fails and then your request failed. No, it can go so that part of your batch goes through and then the other batch fails, part fails, for example, for these throttling reasons that I just told you about. And even in that case, SDK will still return you a success code, so 200 code. So if you only are waiting for an error, you will probably never gonna see any errors with throttling, because for throttling, you will always get the 200 response. Even if the entire batch failed, actually, you will still get the 200 response. Yeah, that's at least what it used to work like. Maybe there have been some changes, but it doesn't really matter. Even if you have one succeeded record in that batch, and then 499 failed records, you should process and detect those errors, right? So it is a very common consideration, once again, in distributed systems in general, not Kinesis specific by no means. In AWS, it's with all the services, or at least most of the services that support batching, like DynamoDB and SQS, they work exactly the same with a bit different flavor of how they communicate to you about these partial failures. So in case of Kinesis, you are in case of actually all the services, instead of just looking at the response or the error code, did you get an error or not, you should look at the actual response that you get from the service. And that response will contain information about the partial failures. And as I said, it's your responsibility to detect those partial failures, and it is your responsibility to handle or retry those partial failures. And if you are not doing anything at the moment, I promise you are having partial failures. They are happening because that's just like reality of things. They happen much more often than you would think. And especially with large enough amount of data, I promise you have partial failures. So yeah, that was a very humbling moment to realize, really.
Yeah, but that's something that you learn by experience, because usually when you go to all these tutorials, nobody shares this.
Well, that's my point. It's usually, or not always, of course, but most of the things you can quickly find online is like how to build simple things. Yeah, it's very easy to build simple things that will work. But then the moment you add a bit of, load, then you see how they actually behave and what's actually happening there. So it's two completely separate worlds. So those hello world examples, they are very useful to get you started, but you should not ever rely just on them. Like, okay, I did it as it was in this video and everything works. Now it goes to product. Yeah, exactly. It works. It goes to production. Well, I mean, don't repeat my mistakes.
That's why we have you here. So after all my Hello World videos, people can learn
But I mean, those are very valuable, and I personally use those kind of easy guides as well to get started, because you get this feel of a service in a way, how things work and so on. Then you can start kind of dig deeper and try to find maybe more information and ask correct. It's always about asking right questions, I would say.
That's what I'm trying here. So good. So now that was the reason why you were losing data then at the beginning.
Yeah, that was the biggest reason, or actually the only reason really, that we were seeing all that problems with our producer application. Or actually, we didn't even see much of the problems. We just all of a sudden started to examine the response, and wow, here we are with large amounts of data just kind of being dropped before even kind of storing it. But the thing here is that it's really, really easy to mitigate. You just have to implement proper error handling yourself. And with proper error handling for either partial failures or any other failures per se, there's just two things that you keep in mind, and you are going to be very well off. So first of all, you always want to set upper limits for retries, any retries. You never want to be retrying forever. I mean, SDK has that. Every smart system, let's say so, should have upper limits, because, retrying forever is never a good idea. And the second one is using proper backoffs. So as I said, SDK uses this exponential backoff. And this exponential backoff and jitter actually means that you add a small random component to this backoff to spread out the retry attempts even more uniformly, more randomly, because you don't want, again, send these bursts of retries, which might end up in a situation when you kind of throttle in one of your shards. So we want to kind of spread them out uniformly. And it's
because if all the producers are failing at the same time and you don't have the jitter, they will all send the messages at the same time.
And imagine they send all these retries at the same time, and then it's going to be not so nice, let's put it so. So you're going to overwhelm a system that is already under tons of pressure. So this exponential backoff and jitter is actually exactly what SDK uses. I just didn't mention the jitter part before. And it's an extremely simple tool, an extremely simple algorithm to use to mitigate like huge amount of problems. And with just these two simple things, you would save yourself a lot of trouble. And once again, this is by no means not Kinesis specific. This is something extremely common. Distributed systems, any AWS services, any retries that you are going to build. And here I absolutely love this quote by your colleague, Gregor Hopp, who says that retries have brought more distributed systems down than all the other reasons together. And yeah, I kind of can relate to this. And this, of course, doesn't mean that you shouldn't retry. You should always retry, as I said, but you should be smart about how you do the retries, because we don't want to kill the system while trying to fix it, So it was basically the first big thing to learn from that experience. Well, for partial failures and proper retries, so with proper backoffs and limits, those are like, they sound very simple when you know about them, but if you don't know about them, please know about them.
Now they know about them.
Yes, exactly.
So now you're ready. Your stream is working fine and everything is happy, joy, no?
Well, kind of, but remember where I started the story. Our consumer Lambda was behaving oddly. It wasn't even the producer. Producer was just
so you found the producer problem because you were looking at
because we were searching for one, and then we found one. Surprise.
Okay, you found the problem because you were looking for
because it was there, but we just didn't know where to look at it and how to find it. But then there was the other side of the story. So there was the story about, or the part of the story about consuming data from the stream. So Lambda that we have. And again, if we show a similar picture about, or a similar slide about how we can consume data from the stream, there are plenty of options. But with Lambda, you get plenty of, benefits when using it as a stream consumer. First, it's serverless. It's truly serverless. And when it comes to reading data from the stream, it handles a lot of heavy lifting on your behalf. So it does things like keeping track of all the open shards in the stream, and keeping track of where exactly to read from each shard, because, Kinesis retains your data, unlike, for example, SQS, it retains your data after you read it. So it's your responsibility to know where to read next, right? And there can be multiple producers, and each producer should track their progress in the stream. So Lambda will do that for you. You don't have to do anything. And then it has a lot of fun stuff like batching and extensive error handling. So that's one thing I'm going to soon be concentrating on. And the thing with Lambda that I always like to bring up is that Lambda is really not this one huge monolith. And it's not this, or it's not the same as your Lambda function. Because Lambda service, it's a bigger concept. It's a service that is composed of multiple different components that work together behind the scenes. And then you have your Lambda function, which is basically your function code or function instance that you are dealing with most of the time. And it's important to understand, because all these different components will kind of affect how Lambda works in different situations. And in case of Kinesis, there is this very crucial component called event source mapping. And I love my unicorn icon that I came up with for this component, because I think it's this, magical component behind the scenes that you mostly don't even think about. You probably don't even know that exists, but it does so much for you on your behalf that it's kind of a bit of a, magic.
I need to submit that icon to the AWS library.
It's a good one, right? But the thing about why is it so important, the event source mapping, is that when you use your Lambda as a stream consumer for Kinesis, you're actually under the hood basically attaching an event source mapping to the Kinesis stream. And then it will be the event source mapping that will pick up records, batches of records from your stream, and then will pass those batches to your actual function instance or function invocation. So it's the event source mapping that handles stuff for you behind the scenes. And again, not Kinesis specific. There's a list of services that use it nowadays when integrating with Lambda, and this list seems to be growing all the time. And for example, Kafka as well uses the same event source mapping, and it will work a bit differently with different services. Currently, only Kinesis and DynamoDB streams actually support the entire set of capabilities that event source mapping comes with. But just to give you an idea, it's much bigger than just Kinesis or Kinesis with Lambda. And maybe one thing again that was important to me personally to understand is that there is these differences in Lambda invocation, right? In general, we know there's a synchronous versus asynchronous, which is kind of quite common to consider when you're building your systems. But then there is this third type of integration with Lambda, and this is called poll-based synchronous. And this is basically what is used for the event source mapping, right? So it's your Lambda and the event source mapping act in a synchronous way. So event source mapping kind of expects a response back from your Lambda function. So if it knows that Lambda function failed, then it does something to that information, but it kind of stays there and waits for it. But from your perspective as like a producer or a Kinesis stream, it still looks asynchronous because, your producer knows nothing about your consumer, your stream knows nothing about the consumer, but then there is this magical unicorn in between that needs to know everything about everyone.
Yeah, that's handling the state of how your stream is going, because as you mentioned, we need to know like where are you reading in the batch, what kind of errors you have. It does a lot of magic. So it needs to understand the magic, like to know what every function is doing. So
Exactly. And then there is this error handling part, which we will inevitably come to, which is tightly related to the synchronous nature of, Lambda and event source mapping relationships. So it's kind of I think in general, I tend to emphasize it that I think it's very important to understand how services work under the hood, even if they look like they work by magic, even if they look like you just combine pieces together and magic happens. You still will benefit from understanding, like we discussed with Kinesis, you will benefit from knowing what's happening there, because when things go wrong, and they will go wrong under appropriate circumstances, you will know what to do next. Like, you will know what is happening instead of just looking at it and thinking, okay, well, things.
At least you will know what to put in the search bar.
Exactly. That's the main goal here, to know what to search for. All right, so event source mapping, we already mentioned that with you, Marcia, is that it does a lot of stuff or a lot of magic behind the scenes. So it kind of picks these batches of records. So not just individual records, but batches of records from each shard in your stream. And you can configure how big or small those batches should be. And again, here it's important to understand that it's still just one event per one Lambda invocation, because that's the nature of Lambda, right? It deals with one event at a time, but each of those events will have this batch inside. And the batch can be just one record, but it's going to be wrapped in a batch. And
be careful with that, because you will run your Lambda concurrency very fast.
Oh, yes, you will. And we will get to that in just a second. But yeah, when you read from the stream, you need to know that you're expecting for a batch and you're processing the batch, even though it's just one event. And when your function is done processing that batch, event source mapping will pick the next batch for you from the stream and pass it to a new Lambda invocation, right? So one invocation per one batch. And here, like maybe a few useful tips and tricks to know. So with this batching, you can actually adjust the size of the batch size on batch window based on the amount of traffic that is coming in. So if you don't have that much data coming in, it might mean that in the default 1 second batch window, which we have like on this upper row here, you will have just a couple of records per batch. So each Lambda invocation will just deal with a couple of records. And as you, Marcia, already mentioned, it's not a good idea to have Lambda processing just like, one record. So you always want to try to reduce the number of Lambda invocations. So in this case, you can make a batch window a bit bigger, like here on the picture below. And that will help you, it will add some time for you to gather a bit bigger batch before Lambda is invoked. And this is just a configuration option in the event source mapping.
It's always a trade-off, how real-time you want your processing to be.
Exactly. And usually both with writing the batches and reading the batches, that's about that trade-off. It's a very good point because, it's a trade-off between how efficient you want to be, how much resources you want to use, how fast you want things to go, how real-time.
How much data you have into the stream. Because if you have a lot of data, then shorter batches will be full of data. Exactly. But if you have one record every week, then maybe...
Yeah, maybe it's a bubble. Maybe then you shouldn't probably use Kinesis, but that's a different conversation. But
let's
you
not
can.
Get there.
Yeah, we are not stopping you by no means. But you touched upon one thing here about if you have like tons of data, right? And what will you? So if you have a low throughput stream, as we call it, so like here in this example, we can just play with these batch sizes and maybe make things more efficient. But what if we have a high throughput stream instead? So what if instead of slowing things down, we want to speed things up? Or we have our requirements for our processing speed so that we want to process as fast as possible, right? So we want as real time as possible. So what are the options for us there? And here again, it's important to understand how Lambda works with Kinesis. I think you, Marcia, have already mentioned that, is that you will have exactly one Lambda reading from one shard in your stream. So to read from all the shards in the stream in parallel, there will be automatically one Lambda kind of dedicated to each shard in your stream, and it will be reading from that shard. So basically, you will have as many concurrent Lambdas reading from your stream as you have shards in your stream, right? And this also applies to on-demand streams. Even if you don't know how many shards there are, you will see in the end that you will have as much Lambdas reading from it as you have their shards hidden under your stream. So it is important to understand. But if you want to speed things up, so have more horsepower, so to speak, you can throw up to 10 Lambdas at each shard in your stream. So you can have up to 10 Lambdas, like you have on the picture here on the right, reading from each shard in your stream at all times. And this is called the parallelization factor, and the maximum value is 10. And it's, once again, a very simple configuration change, basically just one number that you put to the event source mapping configuration, and it will handle it for you. And here, again, as you briefly mentioned, we are dealing very tightly with the so-called Lambda concurrency limit, right? Because, well, Lambda, as wonderful as it is, it comes with its own limitations. And maybe brief explanation. So Lambda concurrency limit is just the amount of concurrent Lambda invocations that you can have at the same account, the same region. So if you reach that, it's a soft limit. You can increase the limit, but I mean, there is still going to be some limit. Maybe it's 3,000.
But it's shared by the account.
Exactly.
So if you have, I don't know, 1,000 in your Kinesis already, and by default, if you don't change it, it's 1,000. So basically, you took it all. Then whatever else you have running in that account will not have any concurrency.
And the problem is not having concurrency sounds benign, but what it actually means is that if you have a different Lambda somewhere who knows nothing about your Kinesis, and it does something, it does something business critical, and then all of a sudden it fails, and you actually don't even know why it fails. If you just look at that Lambda, it's everything is fine. Why is this failing? So it's a huge blast radius that this limit has, this concurrency limit has. And with Kinesis, it's extremely easy to overscale Lambda because, as you said, like we have 100 shards, parallelization factor of 10, and here we are like 1,000 lambdas just reading from the stream, and we are done. So
if you have a high throughput stream, you might reach that one very fast.
And so you should be very, very careful about these things and mindful about these things and keep an eye on the concurrency limit, maybe raise the limit if you need to, and kind of in general be careful with how much shards and parallelization factor you would have in your stream. And that's again something that we were seeing. Actually, it was before parallelization factor, but we still managed at some point to reach the concurrency limit every now and then. So yeah.
That's something. And also when you do the auto scaling, if you increase the shards, you will increase the amount of lambda. So also have that in mind.
Always one shard equals at least one lambda from 1 to 10. And you should kind of always, so everything is interconnected. Like there are ripple effects across everything if you just kind of work with one service. So that's one of these things that I said, like Kinesis comes with great power, but it also comes with great responsibility.
Yeah. So what happened next?
Yeah, so next we finally get to speak about failures in general because, well, that's my favorite topic. And I was telling you there was some really seriously weird behavior going on. So it turned out that there are some very nasty defaults there. Well, they are kind of logical defaults, but when you don't know about them, they kind of can come as a really bad surprise to you. So to recap, event source mapping gets a batch of records. It passes that batch to a Lambda function. Lambda function tries to process it one by one, and then something else happens. But what happens if your Lambda function actually fails when it's processing that batch of records? So you can have a bad record in your batch that your Lambda for some reason can't process, maybe corrupted data or something else, and your Lambda just throws an error and you don't catch it. So what happens next is that event source mapping will be very helpful. It will be there to catch you when you fall and will be there to help you with the failures, but you need to know exactly how it does that. Once again, and by default, a Lambda will try to process that failed batch of records over and over and over and over again until it either succeeds or until the data in the batch expires. So the data expires in at least 24 hours. We have discussed that already. So it means that for at least one day, Lambda will be retrying and retrying and retrying and retrying and failing, of course.
And failing the same place.
Exactly, because well, what can you do? There is a bad record. You can't get over it. So yeah, and imagine if you configured your stream to retain data for like a week or a month, something like that.
A year.
So, or a year. I think there is some limitations for a year, but I'm not completely sure about it. But at least I know that for a week it can easily run the retries without any interference. It can for sure, trust me. So, and as you said, in addition to that, it will actually reprocess the same data over and over and over again, like here on the picture here. Because, from perspective of the event source mapping now, it's not either entire batch succeeds, or it's actually either entire batch succeeds or entire batch fails. So it's quite the opposite to when writing to the stream. Now we all of a sudden will deal with an atomic situation where even one failure in the batch means that the entire batch fails. And then event source mapping is so friendly that it passes that batch back at you. And then you're processing it again and failing again at the same spot and again and again. And 24 hours, one day, however much it is, I mean, you get the picture.
I think
tons of
here for the developers, it's very important to make your operations idempotent, so you can apply the same operation 20 million times, because if not, you are going to do that thing a million times and you're going to get a lot of things over and over.
At the very least, you need to have idempotency. And again, it's a very good and a great comment because, again, not Kinesis specific, surprise. No. Anything, any service. None. Actually, though Kafka apparently states that they have this guarantee of at least once guaranteed. It's called that your record will be there, read only once. But as far as I'm sensing, it's not entirely true. You still can get duplicates even with Kafka. But with Kinesis, it doesn't even promise you that. It tells you at least once guarantee. So we will save your records and we will deliver it to you at least once, but you might get duplicates every now and then. And when there is a word might, it means that they will. I mean, that's just like, that's how the world
and more
works.
When it works at scale. When you have millions
Yes.
and millions of
Yes.
records, the 0.0.1% of
Yes.
might becomes a reality.
Exactly. And if you even think about it, like what we did with the producer, so there are all these retries and stuff like that. I mean, every retry is a possibility for the duplicate. Every retry when reading is a possibility for duplicate. So, I mean, you should always have idempotency, if nothing else. But of course, you should also have proper error handling, right?
Oh, yeah. Because what do we do now here?
Yeah, and before that, even I wanted to mention one more thing, and actually I have it on the slide here, is that in addition to all of that, while we have this reprocessing going on, no other records are being read from that one shard. So all the other shards in your stream, they continue with their lambdas, but that one shard, it's basically stuck with that one batch of records, and it just stuck, and we have all this reprocessing going on, and nothing happens. So, like, that's why it's referred to as this poison pill record, because, well, for obvious reasons, just one bad record was enough to poison the entire situation. And okay, let's hope that we have this 24-hour data retention and the time passes and finally data leaves the system. Okay, you kind of miss some of the data. You don't process the remaining part of your batch, but you can live with that. Life happens. Let's just move on, right?
One question.
Yep.
Is there some way to validate that data before passing it to the stream?
It's a very good question.
Or to the Lambda, for example.
To the Lambda, to the stream, of course, you can always validate what you write to the stream, but it's rather on the other end. Yeah, exactly. What I can come up with is event filtering, actually, and we haven't discussed it yet, but I can try to find you a quick slide because I should have it somewhere here. So basically what event filtering does, it's a relatively new capability that came once again with the event source mapping. But what it does is that it allows you to control what records are you sending from your Kinesis to your consumer. So if your particular consumer is not interested with all the records in the stream, it just wants a subset of records, you can tell to the event source mapping, hey, please only pass those ones to me, right? And then in that way, you will reduce all these unnecessary Lambda invocations that would filter that data themselves inside the code. So you will have less custom code because you don't need to write that kind of a filtering code anymore. And also as a side effect, you will have less records to deal with, so less possibility for the poison pill to happen, right, in the first place. And it's a very simple tool to use. So it's just a filter, a JSON-based filter, just like in EventBridge, actually. And you can filter based on your metadata or the data itself. And when I say you can use it for kind of validation, is what I mean is, well, first of all, let's kind of trace back a little bit. So what does a bad record mean? So it can mean one of the two things. First, it can mean either that there was some invalid JSON, so something that wasn't supposed to be there. So it will be like bad for all the consumers of your stream, right? Nobody will be able to process it because it's corrupt. But then it can be like bad data from perspective of your specific consumer. So that specific consumer expects data to contain some specific fields. And when it doesn't find those fields, it might fail for some reasons, So that also can, even though the data is valid by structure, it might not be valid for that particular consumer. And here the filtering can help a lot because if you know what you're expecting, you can add it to the filter, and then only the records that will have that fields will be passed to your Lambda. So in a way, you do pre-validation, but it also will help with this invalid JSON situation because the way it works is that if you have a filter and if Lambda received an invalid JSON in your data field, then those records will be just ignored automatically. So they will not even get to the Lambda invocation. They will be pre-filtered before Lambda happens. So this will reduce, in my opinion, vastly reduce the possibility of this kind of a poison pill. But that's one way that I can come up with related to
but I think it's a simple way to apply to your event source mapping of little filter there with whatever you are searching in the processing of those records. You need these attributes, just put it there. And you save a lot of headaches.
And the thing is that, again, with filtering, I always say that it's one of my personal favorite capabilities, though it looks very small, but actually it does such a huge job and it costs nothing. So it basically saves you all this computational time and power that you will spend on filtering yourself. So you're not built for that. And also it's so simple just to add this configuration when you're creating your event source mapping, and you can change it at any time. So it's really great. I would really, really recommend it to use it in basically all the cases when you at least know what the data should look like.
Yeah. And I have another question about this poison pill. Now, imagine that the data cannot be processed. It expires. Is there some way to send it somewhere so we don't lose the data?
Yes, for sure. And here we come to my favorite part of the
everything process. Is your favorite. You're like my toddler.
I don't know. Maybe. Thank you. I take it as a compliment.
Yeah, she likes everything.
Well, I tend not to, but now when you mentioned it, maybe this story has become so close to me that I tend to like everything when it comes to it. But I guess because everything revolves around failures, it's so fascinating. So yeah, but thanks for the compliment. So when it comes to failures, and maybe like to trace back a little bit, again, we ended up in this situation only because we didn't know better and just went with these good old retries that Gregor has warned us about, and we did nothing. But there are tons of simple or several simple things that you can do actually to mitigate that, as you were referring to. And that's actually the situation that we were seeing in our actual story that I was telling you. So we had this repeated prolonged burst of Lambda invocations. We had plenty of duplicates. We had delays. Of course, we had some extra costs because, well, we both know Lambda invocations are not free. And last but not least, we were losing the data. So this was the bottom line of that story. And the things that we can do to make things work pretty easily, they will come with the event source mapping once again. And first and foremost, once again, we need to set up those limits. So we never ever want to retry forever. We want to have limits for that. And by default, as you can see, actually Kinesis or event source mapping has no limits. So it's both limits that are related to retry attempts, they are set to -1, which means no limits by default. So here we are ending up in this wonderful situation. But then there are two things that, in addition to that will help you like automatically reprocess the batch with failed records. So first there is this batch bisecting, which is basically just splitting the batch recursively and sending the part separately or processing the part separately until you hopefully end up with just this one batch record, and all the other things actually get processed in the end. So you don't write any code for that. Once again, it's just a checkbox that you use in event source mapping configuration. You allow Lambda to do that. But it will lead to a lot of reprocessing once again, because you have all this splitting. So this last option is called partial success or partial failure. I'm already confused because the names are used interchangeably, but it basically means that you tell to event source mapping explicitly which record failed. So you tell that it was, in this case, this record 4 that failed, and it will not send the records 1, 2, and 3 to you anymore. So you will avoid all that reprocessing. And this, again, to trace back, is due to this synchronous nature that we have between Lambda and event source mapping, because event source mapping actually waits for a response from your Lambda. So that's why it's important to know how those things work. And kind of getting back to your question, after all that retry attempts, after all that you tried to do to process those poor records, you can still fail, of course, but by no means you shouldn't discard those records. So you should allow Lambda to send them to a so-called failure destination. And in case of Kinesis, it can be either SQS or SNS. So again, just a matter of configuration. And you basically create a dead letter queue where Lambda will send automatically the failed records, or again, to be fair, not the records themselves, but the metadata about the records. So you still will have to go and pick those particular records from the stream. They are not going to be duplicated to your destination. Yeah.
Okay.
And that's a catch that many kind of, again, learn the hard way, because they think that now the records are in dead letter queue and I have plenty of time to process them whenever I want to. But the reality is all you have is the metadata, kind of a pointer to the place where things went wrong in the Kinesis stream. So the records will still expire in 24 hours or whatever time you have set for your stream. So you have to go process them before that happens. So it's a very important.
So here is It's very important then the difference, because I think it's very confusing sometimes, like the record age and the amount of time your record lives, because you're like, oh, if I have my record to be 24 hours in the stream, why I will care about the record age on how long it will be processed. But here it becomes very important. You might want to have a longer retention in order to go and find those failure records, but then you might want to send your record age to be what is meaningful for your application.
Excellent comment. Yeah, exactly. Because those are two kind of separate things, and the record age comes at play when things don't go as planned, let's say. So while the retention period is something that gives you the buffer, the time to react to things happening. Like, for example, you have a production system, it was done over the weekend, and you can be sure that on Monday you go there and the data at least is still stored, and you can kind of deal with it if you have a longer period, retention period. But of course you have to pay extra for that, but all good things come at a price. But those are two different time settings that you should be aware of. And record age setting costs you nothing. So it's something that comes for free from the event source mapping unicorn.
I love that icon. Good. So did you fix your problem now? Did you figure out what was the issue?
Yeah, actually, in the end, as I said, that was exactly the case that we were seeing with all these retries and all that stuff. And again, the simple lesson from all of that, don't go with the defaults. Defaults are dangerous. Defaults are bad. And maybe going with the defaults doesn't force you to learn about how things actually work, which in my opinion is not such a good thing. With production systems, with big scale systems, with real world systems, please try to figure out how the services that you use, how they work, how they interact, most importantly, how they fail, because they are failing. I promise you, because it's not a criticism towards AWS by no means. It's just a reality of things in the world of distributed systems. And I love this quote, of course, as many do, from Werner, who says that everything fails all the time. And I felt so seen when I first time heard that quote from him. So I use it everywhere now, because that's true. So we just need to be prepared.
It's scary, but it's relaxing, because you're not alone.
It kind of takes the pressure off. Okay, I will fail. So what do I do next? How do I get prepared? How do I get something positive out of it? I got a lot of good stories out of it, so that's a positive. But I learned a lot out of it. I try to teach others to learn from my failures, not to fail themselves. But so failure is not necessarily a bad thing. It's just a reality, That's how things work.
Is there some way to prepare for these failures, like load testing, I don't know, having some chaos engineering with Kinesis? How you will prepare for this?
Well, first and foremost, as I said, I would personally try to learn as much as I can about the failures and about the service limits. So there are always these common considerations, once again, common to distributed systems, like service limits and error handling. Every service has it in different ways, partial failures, retries, backups. Those are the things that we kind of always need to have in our workbook. So every time we face a new service, we just open the workbook and go step by step and okay, check. I know how this works and how this fails and what happens next. And then you can kind of start iterating from there. Load testing is I guess the best tool for that. That's what I have been personally doing as well. So after you are done building a POC with all these basic considerations in mind, that the system works, then you can iterate on that. You can start load testing. You can see how it's gonna perform under load, because you are going to be surprised. It's going to be completely different. Sometimes it works much faster under the load. There are services that are meant for big load, like Lambda, like DynamoDB. They actually speed up with bigger load, which was a huge surprise to me at the time, because they are built to work under big load. So you might actually get benefits from that. But then there are services, or actually always there are extra considerations that you need to have with all the limits and all the throughput and stuff like that. So load testing, by all means, integration testing end to end, like you said. And you don't even need any advanced tools for that. I used to build very simple APIs that just generate, ginormous amount of records and then just send them forward, and then you see what happens on the other end, and that's already kind of a great weight. Everything is better than nothing at all.
And there's many tools, at least, for doing load testing nowadays, so you can have fun in a serverless way. Because I remember when I started load testing in the past, it was like, oh, I need to set up an EC2 instance and run this thing.
Right. Things have evolved a little bit since then, so there's plenty of options to do that. And again, it's not service specific; it's just the way you load test things in the real world.
And more when you work with all these different components is super important, because as you say, the limits sometimes are not matching each other. You might have a service that by default scales automatically and doesn't have much of a limit. And then you have services that have some limit. Yeah. So even though the limits are easy to change and it's just a ticket to support and they will change it right away.
Some limits,
you need to know.
Hard.
Yeah, sure. But you need to know.
Of course, that's basically the main point that I'm trying to preach for all these years. Whatever you do, first you need to have the knowledge, you need to have the information. And after that, you can kind of act or react based on that information. But if you don't know, you don't know. That's like a simple kind of reality.
Yeah, and I think with that quote, we can end our conversation today, because you have took us in a kind of journey of errors and solutions.
I hope it wasn't
if you
all
came
negative.
to this video, no, I think no. And I want to ask the people watching, if they found this video when they had a Kinesis problem, leave me in the comments and say hi to Anahit.
Really would love to hear from you.
Yes, if you found this video because of that, just give a heart in the comments.
And
she help you.
I will have to do the bit of advertisement here, as I said in the beginning. It's going to be a very exciting reInvent this year for me, so I'm going to be speaking there. So if you happen to be around, please come to support me, and please come to learn maybe something else that I didn't mention today. So that's a big thing that is still coming this year. And also I have these articles written about Kinesis and Lambda. They are really huge, but they go in a lot of details into everything. So again, if you find this topic interesting, please go check them out.
Yes,
shameless plug is over.
I think it's good. I will leave the link so people can click them from their computer in the description box. So it's easier because sometimes they're watching on their phone and scanning a QR from your phone. It's just hard.
I know. This is more of a placeholder, I would say, like a pressure for you to add some links there.
And with that, I will thank you, Anahit, for hosting this thing with me today. It was awesome to have you here, and it's always a pleasure to talk with you, and I hope you had fun.
Yeah, thank you so much. I always have tons of fun talking about failures. And it was really great talking to you. Thanks for having me, and chat to you again someday.
Yes, and everybody, thank you again, and let's see in another episode of FooBar. Ciao, ciao!